Hello everybody, today I'm going to show you how to make the golden rectangle just by folding and without measurements. And this is pretty cool. So first, without actually getting started, I'm going to show you what the golden rectangle is. And the basically a quick thing is the golden rectangle's sides are in the ratio of 1 to 1 plus the square root of 5 all over 2. So let me just write that down. 1 plus the square root of 5 over 2. Okay? And that's what it is. So now that we've got that done and cleared up with, we can start going on with how to get the golden rectangle actually. So how to get it, first we're going to just draw this guy. And so we need a square first. And then what you're going to do is you're going to fold the square in half. Then you fold from here to here. I'm just going to do this pretty quickly. And then you angle bisect this angle right here. So you bisect this angle. And by angle bisecting, I mean, first I'm going to draw this. By angle bisecting, I mean that these two angles are equal. And how you do that is you just take this side right here and you just fold it over to the side. So you take this side right here and then you fold it over to this side right here. And you'll get that this is exactly the angle bisector. And this line right here is just what happens when you fold from the intersection point right here. And what you'll have that, let me just shade in this square. You have that, rectangle. This rectangle that I just shaded in is the golden rectangle. Now, what we're going to do is we're going to prove this. But first we'll have to explain what the angle bisector theorem is. For the proof of the angle bisector theorem, you'll have to go search that up because, of course, I'm not going to explain everything in this video. But what the angle bisector theorem essentially states is, let's say you have a triangle and this is the angle bisector of the triangle. So these two angles are equal. And this guy, this length is A, this length is B, this length is X, and this length is Y. And what the angle bisector theorem states is that A over B equals X over Y. And we're going to utilize this because we already see that this is angle bisected. But the problem is that we see something wrong because obviously this weird trapezoid looking thingy is not actually a triangle, and that's a problem because we need a triangle in order to use the theorem. So people were smart and they came up with a better solution. They extended this so it goes out, and they also extended this line right here. So yeah, and we now have a triangle, which is perfect because now I can use the angle bisector theorem on this triangle right here. So we start by noticing a few things. First, we're going to start by calling this side right here X, and we're just going to have to find that X has to be some value. And second, we're going to assume that the side of the square is 1 to make things easier. So therefore this side, this little thing right here is 1 minus X. And next, what we're going to do is, we have to find out what X will be. Since we know that this rectangle is in the ratio of, let me first put this as 1 because we know it's already 1. And since we know that this rectangle is in the ratio of 1 to 1 plus square root 5 over 2, then this has to be in the ratio of 1 to, to 1 plus square root 5 all over 2. So that's our ratio. But we notice that if this side is 1 plus square root 5 over 2, then that means this side would be longer than this side, which isn't true. Which means that ours is actually in the ratio of 2 over 1 plus square root 5 to 1. So this side is actually 2 over 1 plus square root 5 to 1. So that's actually what we're supposed to prove. So now we have to find that this guy is 2 over 1 plus square root 5. So first we notice that these two triangles, this triangle is congruent to this triangle by side angle side, because we notice that this, these two triangles are congruent because this slope is 2, which means this slope also has to be 2, and therefore this has to be length 1 since this is length 1/2. Now that was kind of confusing, but just assume that these two triangles are congruent, and you can kind of see it. Like if you took this gigantic block and you moved it up here with the line inside of it, it kind of makes sense. So now we know this side is length 1, and by the Pythagorean theorem, since this length is 1/2, well, actually we'll just do this whole side, which is 2, and this side is 1, then we know this whole length is the square root of 5. From there, it is clear that we can now use our angle bisector theorem. We see that we have our x, we have our y, we have our a, and we have our b. And now we can execute our theorem on this. So the first thing that we do is we just add these two and we apply our theorem. So we know that 1 over x now equals this over this side, which is square root 5 over 2 minus x. And then we do our cross multiplying and we get that. I'll just do this. Whoops. Keep writing extra. Okay. And then we divide by, well, first we add x. We add x, and then we have 2 equals square root 5 x plus, I keep messing up, plus x. And then we factor the x out and we divide, and we get, once we factor the x out, we'll get x times 1 plus square root 5 equals 2. And therefore, we are done because x equals what we wanted it to be, and we've proved that this guy right here is a golden rectangle, and I'm going to keep writing. So therefore, from all of this work, we see that this rectangle is the golden rectangle, which is pretty cool because with so many steps, it's so simple to get the golden rectangle just with a square, and you just need a few folds just to get the golden rectangle done. And I hope you enjoyed. This was a pretty long video, so you might have fallen asleep during this video, but at least you got the idea how to make the golden rectangle just with origami. Thanks for watching, and I hope you enjoyed.